Welcome everyone to the Explainer. Okay, let's dive into this. Today, we're looking at a genuinely fascinating thesis project that sits right at the intersection of cutting-edge technology and human well-being. It's titled Explainable AI for Medical Diagnosis, Enhancing Transparency in Disease Prediction. And we're going to unpack exactly how developers are trying to fix one of the biggest, most glaring flaws in modern medical tech.
To start, I want you to imagine you're sitting in a doctor's office. The physician walks in, takes a look at your chart, and delivers a highly specific, totally life-altering diagnosis. It's perfectly accurate. But when you ask, "Hey doc, how do you know? Like, what are the signs here?" They just stare at you blankly and say, "I can't tell you. You just have to trust me." I mean, would you accept that? For almost all of us, the answer is a resounding no way. We need to understand the reasoning, right? We need that transparency to actually build trust. And yet, crazily enough, this exact scenario is playing out right now, not with human doctors, but with artificial intelligence.
Which brings us to a major roadblock in modern medicine. We call it black box AI. See, right now, artificial intelligence has achieved absolutely remarkable performance when it comes to medical diagnosis. I mean, these state-of-the-art models process vast amounts of data and give incredibly accurate predictions, but they operate as total black boxes. They give you the answer, sure, but they are completely incapable of explaining to healthcare professionals why that specific prediction was made.
So, let's move to Section 1, the black box problem and the tension in modern medical AI.
You see, that lack of transparency, it creates this massive tension, and it led the project team to a really profound realization. High accuracy alone is simply not enough in healthcare. Think about it. In medical decision-making, transparency is every bit as important as accuracy. If doctors are going to prescribe intense treatments, or if patients are actually going to agree to them, they need explanations they can truly trust. A computer model just spitting out a percentage doesn't cut it when human lives are literally on the line.
So, on to Section 2, a transparent solution. Introducing Explainable AI.
How do we actually bridge this gap between powerful machine predictions and human comprehension? Well, now, what's really interesting about this slide is the clear contrast it draws to answer that exact question. On the left side, we've got traditional AI. You feed a patient data, and it spits out a binary result, positive or negative. Boom, end of story. But on the right side, we have the project's ultimate goal, explainable AI. Instead of just handing down a final verdict, this transparent model actually explains which specific medical factors influence the prediction and exactly how strongly they contributed to that final answer. It finally opens up the box.
And to prove this concept actually works in the real world, the development team didn't just build some theoretical model. No, they built a comprehensive platform targeting 3 very real, very high-stakes conditions. Their system predicts heart disease and diabetes using structured medical records, and, this is super cool, it can actually detect pneumonia just by analyzing chest X-ray images. So they grounded this highly abstract technology in diseases that impact millions of people globally every single year.
All right, Section 3, building the explainable AI. Let's look under the hood.
So how exactly did they put this whole thing together? Well, the team followed a highly structured 4-step pipeline to construct this transparent AI system completely from scratch. Step 1 was data collection, gathering all those raw medical records and images. Next came Step 2, model development, where they trained the actual algorithms to recognize the diseases. Step 3 was the secret sauce, explainable AI integration. This is where they hooked up the tools that translate the AI's complex math into human logic. And finally, Step 4 was building the user interface, creating a really patient-friendly web app where doctors could actually upload files and see these transparent results, complete with confidence scores and clear visualizations.
Looking a bit closer at the raw materials they used, the team brought in some very well-known public datasets to train their system. We're talking about the UCI heart disease dataset, the PIMA Indians diabetes dataset, and a specialized chest X-ray dataset. Now, to process all this diverse, messy information, they utilized several different machine learning models. For the structured data, things like your blood pressure or glucose levels, they used models called Random Forest and XGBoost. But for the incredibly complex medical imaging required to spot pneumonia, they deployed a heavy-duty deep learning model called DenseNet 121.
And this brilliantly illustrates exactly how they achieved that crucial transparency we've been talking about. They integrated distinct explainable AI tools to act as literal translators between the machine and the clinician. First, they used a tool called SHOP to show global and local future importance, which is essentially ranking which symptoms mattered most overall and for a specific patient. Then they used LIME for instance-level explanations, breaking down those individual predictions. And for the chest X-rays, they used something called GradCam. This one is amazing
because it actually provides a visual heat map right on the X-ray itself, showing the doctor exactly which part of the lung the AI was looking at when it detected pneumonia.
Let's transition to Section 4, Overcoming Developer Challenges, or the friction in the process.
Of course, building a system that is both incredibly smart and wonderfully transparent, yeah, that is not easy. Creating trustworthy AI is incredibly messy work. The team highlighted 4 major hurdles they had to clear. First up was a classic AI tension, balancing accuracy with interpretability. Because, often the most accurate models are also the most mathematically complex and therefore the hardest to explain. Finding that sweet spot took a ton of experimentation. Second, they had to deal with dataset quality. Messy, imbalanced datasets with missing values meant they had to do a lot of heavy lifting in pre-processing. Third, they had to integrate completely diverse AI models, smoothly combining structured data with deep learning image analysis into one single platform. And finally, the ultimate challenge, generating explanations that were technically accurate but still entirely understandable by both healthcare professionals and everyday patients.
Section 5. The Future of Healthcare. AI as an assistant, not a replacement. Despite all those challenges, the team actually successfully built the platform. But they definitely aren't stopping there. The developers have a really clear roadmap for where this exact technology is heading next to reshape the future of medical care. They plan to pursue real-time hospital integration, meaning this wouldn't just be a standalone web app on a laptop, but something that works live right on the hospital floor. They want to add electronic health record, or EHR support, so it speaks the exact same language as existing hospital databases. They're also planning multilingual interfaces and voice-assisted interaction to make it totally globally accessible. And crucially, they are aiming for rigorous clinical validation with actual healthcare professionals in the field.
So, the crucial point is captured beautifully in this quote straight from the project's source material. In healthcare, understanding why a prediction is made can be just as important as the prediction itself. The team's vision here is absolutely not to build an AI that replaces doctors. Their goal is to build an AI that assists them. By combining raw predictive power with crystal clear explainability, this project aims to support clinical decision-making, improve human trust, and make artificial intelligence truly practical for real-world healthcare.
Which leads us with a pretty fascinating question to consider. If AI is here to act as an incredibly brilliant, fully transparent assistant to your doctor, rather than a mysterious black box that just replaces them, how will transparent algorithms change your next medical visit? Just imagine your doctor showing you an AI-generated heat map of your own X-ray, explaining exactly what the computer sees, and then collaborating with that technology to get you the best possible care. That is the true promise of Explainable AI. Thank you so much for joining me for this explainer. Keep asking the big questions, and I will see you next time.